Hey everyone, my name is Sahil and in today's video we will be discussing the rolling sphere method which is used to design lightning protection systems. In this video, I will be discussing what is the rolling sphere method, its radius and outer zones, air termination calculations using the rolling sphere method, and the penetration depth calculation, which is an important consideration for lightning protection design. So let's start by understanding the need for such methods. Essentially, the rolling sphere method is one of three routes for the design of lightning protection systems defined by IEC 62305, which is the international standard for lightning protection design. After the first step of determining the class of lightning protection decided by the risk assessment, the lightning protection for buildings and system design can be done using the rolling sphere method, the protection angle method, or the mesh method. The system design will provide information such as the location of lightning arresters, down conductors, earth electrodes, and other required equipment. So, what is the rolling sphere method? Essentially, it is a simplification of much more complex lightning protection design methods intended to save the designer's time and effort. It helps in identifying the areas of a building or structure that need protection from lightning. This method also takes into account the possibilities of lightning strikes to the side of buildings. As you can see here, a sphere with a radius defined by the class of protection is rolled across a structure, and wherever the surface of the sphere comes into contact with the structure, it is considered to be unprotected, thus requiring air termination. Now, let's discuss the radius and outer zones of the rolling sphere. As we can see in this table, the radius of the rolling sphere changes as per the different classes of lightning protection. Class 1 has the smallest rolling sphere radius of just 20 meters, while Class 4 has the largest sphere of 60 meters. As a result, buildings with Class 1 protection are the ones that are the best protected. Now, let's discuss side strikes. Irrespective of the radius of the rolling sphere that you end up using, whether it is 20 meters or 60 meters, side strikes could occur on buildings that are higher than the radius of the rolling sphere. The probability of these side strikes is negligible on structures less than 60 meters in height. Therefore, as you can see in this drawing, even though the rolling sphere is touching the side of the building, but because the height of the building is less than 60 meters, hence its sides will be a protected zone against side flashes. But if the height exceeds 60 meters, then the side is no longer protected and is therefore susceptible to side strikes as per IEC 62305. Now let's discuss zones of protection. The rolling sphere method allows designers to divide the outer structure into distinct lightning protection zones. We have explained lightning protection zones in detail in our blog, Lightning Protection Zones and their application to SPD selection. The link is in the description. IEC 62305 Part 4 has defined these lightning protection zones as Zone 0, where the threat is due to direct and indirect lightning strikes, and where the internal systems may be subjected to lightning surge current. Lightning Protection Zone 0 is further divided into two zones, LPZ-0A and LPZ-0B. LPZ-0A is a zone where the threat is due to direct lightning flash and the full lightning electromagnetic field. Here, the internal systems may be subjected to full lightning surge current. LPZ-0B, this zone is protected against direct lightning flashes, but here the full lightning electromagnetic field is still a threat. However, the internal systems may be subjected to partial lightning surge current. First, let's do the calculation for the separation distance between air termination rods. When multiple air termination rods are to be used to protect a flat surface, you can use this simple formula to calculate the separation distance between the rods. There are just two variables to use in this formula. First of all, R, which is the radius of the rolling sphere, and H, which is the height of the rods. Now, let's discuss the last part, which is the penetration distance of a rolling sphere. When designing the air termination system for a building or for a roof mounted structure, the penetration depth of the rolling sphere between two air termination rods becomes a key factor. Penetration depth is important because it determines the maximum height of any object between the two air termination rods. If an object exceeds this height, then it is no longer protected and is susceptible to lightning strikes. This is the formula for the penetration distance calculation. where P stands for the penetration distance, R is the radius of the rolling sphere, and D is the distance between the two air termination rods. I hope you now have a better understanding of the rolling sphere method for lightning protection. At Axis, we have a large team of engineers who are here to help you with designing and installing your lightning protection and earthing system. Our products have been used from large-scale data centers to just everyday residences and commercial buildings. Please share your feedback and queries in the comment section below. If you like the content that we are making, please like and subscribe to our channel for more videos about lightning protection and earthing systems, along with other videos about electrical engineering. I'll see you in the next video.